Hi, we are moving on to the time instruction group in today's video. The time instruction group consists of timing and counting. The first of these instructions is the timer on delay, TON. To explain the timer on delay operation, first, drag a contact with variable s.1 into an empty rung. Also, drag a timer on delay into the same rung. Right-click on the question mark before the timer label on the timer to select t.1 variable. These are the status and data variables of the timer. EN status becomes true when the rung condition is true. TT status becomes true as long as EN is true. If the preset value in PRE elapses, then it becomes false. DN status becomes true only when the preset value in PRE elapses. The ACC data value increases in proportion to the time base when the EN is true until it is equal to the PRE value. Double-click on the question mark before preset to assign a value of 10 to it. The time base can be set to either 10 milliseconds or 1000 milliseconds. Let us leave it at 1000 milliseconds. Then click on the check to accept the value. When a rung condition is true, the timer on delay will wait for the preset value multiplied by the time base before the timer output status will become true. Go to simulation mode and set the S.1 contact to true. Notice that EN color first changed to green and then TT. Also, observe that the ACC value increases by 1 second until the preset value of 10 is reached. Then TT color changes to black, while DN changes to green, indicating the completion of the timing. When S.1 returns to false, EN and DN becomes false, and ACC value is reset to 0. Hold down the right mouse button on S.1 button until the timer ACC value is about 5 and release it. Observe that when the rung condition becomes false, before ACC value gets to 10, DN status will remain false and ACC will reset to 0. Let us now use the status of DN to enable an output. First, add a new rung and drag a contact and a coil into it. Display the peak data window and select timer from the drop-down menu. Drag T.1.dn to the contact and 1 from the relay drop-down menu to the coil. Simulate the program and observe that when S.1 contact is true, the ACC value increases. When it matches with the preset value, DN status becomes green, which then changes arrow.1 status to green through the contact. Using the circuit setup of previous video, upload the program to the PLC. Observe that when the push button switch is held down, the indicator is delayed for 10 seconds before it comes on and goes off when the button is released. The timer of delay instruction output status will wait for the preset time to become false when the rung condition changes from true to false. Now, delete the timer on delay and drag a timer off delay into the same position. Notice that the data and status variables on the timer are the same as that of the timer on delay, except for TOF. Assign variable T.1 to it and a preset value of 10. In simulation mode, change S.1 status to true by clicking on it in the simulation window. Observe that DN color changes to green, which makes arrow.1 true. Now, change S.1 status to false. Observe that TT color is now green, while the ACC value starts decreasing from 10. When ACC is 0, DN status changes to false, which also make arrow.1 become false. Upload the code into the PLC and hold down the push button switch. Observe that the indicator lamp comes on. When the push button switch is released, the indicator delays for 10 seconds before it goes off. The retentive timer on works just like the timer on delay. The difference is that while the value of ACC resets to 0 when the wrong condition goes to false from true for the timer on delay, the retentive timer on ACC will retain its value. When the wrong condition becomes true again, ACC value increases from the last value until it matches the preset value. Delete the timer off delay and drag a retentive timer on into the same position with the same parameters. Insert a third rung and insert a contact with variable s.2. Then drag into the rung the reset instruction from the time instruction group and t.1 variable from the peak data window. In simulation mode, click on the s.1 contact button in the simulation window. Observe that the timer ACC value increases. Click on the button again and observe that ACC stops increasing. A third click on the button causes ACC to increase until it is the same with the preset value. Even when ACC value matches with the preset value and s.1 is false, ACC value will not return to 0 without a reset. Click on the simulation button for contact s.2 to reset the timer to 0. That is all for today. Thanks for watching. You must have enjoyed this video. Please click on the like button and leave a comment in the comment section below. Hope to see you in the next video.